And thank you for taking the time out this morning to join this event and participating in this panel. And I can leave it off to you guys. If you would like to introduce yourselves, and I just take it from there.
Sure, sounds good. Thanks for having us. It's good to be here. My name is Nick Dugan, and I am the Deputy Chief Information Officer at UC Merced. I have been on campus here for about 11 years, and I am responsible for the teams that run our campus IT operations. So that's everything from the campus network to our cloud and local computing infrastructure, to our enterprise applications group, and also a data services team that runs a number of our databases and some analytics platforms that we use as well. So I'm happy to be here. I'm excited to have Nick and Roger with us as well, because I think they will both present a very different point of view around cloud computing and cloud systems in general, from both a sort of an infrastructure management and a software development perspective. So I will let them introduce themselves and we'll go from there.
All right, I'll go next. I'm Nick Hansard. I'm the Director of Cloud Services and Infrastructure Operations in the IT department at UC Merced. My group is responsible for all of the on-premise and cloud infrastructure, so the servers and storage and systems that run all the wonderful applications that we support. Our primary cloud vendor for general purpose stuff is Amazon Web Services. We have a fairly small AWS footprint at this point, but it's been growing and ramping up pretty significantly over the past year. And then other cloud services that we use are Office 365, the full Microsoft cloud stack there, and then other things like Box and ServiceNow and Canvas and lots of other applications that are more SaaS-based applications. Just like Nick said, he'd been here for a while. I think I'm one of the longest term serving people in the IT organization. I've been with UC Merced since October of 2004. So I think that's like, what, 15 or 16 years now? I don't know. It's been a while.
I'm Roger Borges. I'm an architect in IT, but really in practical terms, I probably see myself more as a jack of all trades software developer type of person. I've been with UC Merced for about 7 years, so since July of 2013. So the first time I started working in cloud systems is actually here at UC Merced. So when I started my career, there wasn't much of any sort of cloud to speak of. So it's been a very rapid evolution in software development over the years. So yeah, that's me.
Great to have you guys here. So we can start it off with, sorry about that. Just asking you guys, like, in your terms, what is cloud system development, and what would you guys say you would do on like a daily basis?
Sure, I'll go first because I think my answer is going to be quickest. So to me, cloud systems and services in general, I'd say are, I guess the best way that I could put it is sort of the commoditization of internet infrastructure, of computing infrastructure in general, right? When I started my career, if we wanted to stand up a new application, we really ran the whole gamut of everything from buying a server to racking and powering and cabling that server, installing an operating system on that server, installing a development environment for our developers to begin developing the application, and then all the iterations that come with that of managing and maintaining that those resources over time. Cloud computing has really changed that for us in sort of the way that we work, and that the infrastructure at this point has largely become a commodity. There are a number of large internet scale corporations out there like Amazon Web Services, like Microsoft, Google, for example, that are doing that at scale and are doing it much more cost effectively than smaller organizations like us can. So the shift there from the infrastructure perspective was really pretty dramatic, and that that really, I like the way Roger put it, that sort of happened to me in the course of my career. That technology evolved, and in order to remain current and move forward, we were sort of forced to adapt that and evolve along with it in the way that we provision our infrastructure, our applications, things like that. And that runs from everything from the actual physical servers themselves to the applications that we provide to the campus community. So 15 years ago, everybody ran their own email servers, and had servers and infrastructure and local software that was run in a data center somewhere on campus and provided email service to everybody. That's a software as a service now. Microsoft does that, Google does that. We run none of that infrastructure. It's really just a subscription for us. So the responsibility for the maintenance and operation of some of that has shifted from really a capital expenditure for servers and data centers and software, things like that, to a subscription service that we pay annually. So my job, my day-to-day interaction is really kind of runs the board. At this point, I'm largely a bit more hands-off at this point because of my position in the organization. I'm more at the sort of people and project management level, and coordinating strategy and things like that at a larger level around the direction that we're going with a number of our platforms, services, applications, and things like that. But Nick and Roger, I think, are much more sort of involved in the day-to-day aspects of actually managing cloud services, developing applications that run in the cloud and things like that. So it's probably a good time to hand it over to them.
Yeah, so from an infrastructure perspective, Nick alluded to a little bit that I think that the work that my team, as we were classically, we were called sysadmins, and we were responsible for the procurement, the racking, the stacking, the cabling and power, and all the maintenance of physical hardware devices in our data center. Over the past probably 10 years, there has been a pretty drastic shift from each individual application or system needing its own physical hardware to kind of as an interim step to what was initially considered as virtualization, and VMware being the big player in that space, and kind of shifted into the concept of a private cloud where you're abstracting the systems that you run away from the hardware, so that the hardware that it's running on doesn't matter so much, as just that you have resources to support the systems and the workloads that you're running. To now, those things are shifting into public cloud, so AWS or Azure, GCP, public cloud providers. So a lot of the work that was done, when we used to have to worry about setting up RAID arrays and laying out storage and buying additional drives to expand hard drives, or memory and CPU capacity in physical boxes, is now more focused on making sure that you've assigned the right number of resources to any given workload. So if your application needs to be able to scale out or scale up, that you can do that pretty quickly based on kind of on-demand public cloud infrastructure. And then I'll throw it over to Roger so he can talk about how that really kind of impacts things from the programming and application level.
Yeah, so I'm trying to think of how to frame what I'm going to say. So before cloud, so there's before cloud and after cloud as a software developer. So before cloud, what you were focused on is what frameworks you're going to use, and maybe arguing with your team and the IT department about what they can support on-prem and things like that. And then switching to cloud. So if you're still a coder and you're switching to cloud, you're primarily going to be working in something like AWS or Azure or maybe GCP now. And so what you're primarily focused on is, yeah, your framework, but most people don't care what framework you're using. What they care more about is the cost. So as a developer, you have to go into those cloud providers, and now you have to be the one to do the cost calculations and estimations and projections in order to propose something new, for whoever you're working for. So that part is completely new as a cloud developer. You have to be on top of those things. And then not only that, but you have to be able to project what the cost is going to be at full scale. So if you're going to be, serving to 100,000 people, you need that hardware to scale up, and it's going to be a lot more expensive than when you're building it for 10 people to use. So those are, a lot of things that you have to consider now that you're a cloud developer. Another thing about being a cloud developer is there's what I just mentioned. So just switching your code from, a non-cloud system to a cloud system. But you also have these sort of cloud providers that are, they're not AWS. They're more like platforms that you build on top of. So I work with a platform called MuleSoft, and we do data integrations. And so MuleSoft provides a lot of the underlying infrastructure and frameworks for us, and then we just deploy into their cloud systems. And so what we really can focus on is delivering the integration itself and not focusing so much on things like frameworks. We basically are given the framework, and we can focus on requirements and delivering. And that's a very effective way to build software and to not worry about, underlying things and going down rabbit holes. What you really got to focus on is talking to your customers and making sure that you're building what they need. So that's an entirely different way of thinking from, 10 years ago when you're just building web apps on an on-prem system. So, and then there's even more abstracted out systems, I guess you could say, from a software developer's perspective. There's like no code platforms where you don't write any code, but the reality is you still have to write code for some of these systems. So one of these cloud systems that we have here at UC Merced is called OnBase, and that's a system that we use to stop doing paper processing and do everything digitally. So it's forms. You fill out forms, and it's supposed to be a no-code platform, but we have to get UC Merced data into OnBase somehow. So that's where the coding comes in. You have to get these disparate systems that don't know how to talk to each other. And then that's where the coding comes in. It's those connecting pieces now. As a cloud developer, you got to build those connecting pieces. So yeah, that's about it for me.
Yeah, thank you for that. What would you say your career path towards cloud systems was? Like, how did you decide to get working into that field and become a cloud developer, or like how you were roped into it?
I will say, for me, like I alluded to earlier, I think the cloud sort of happened to me, and the choice was sort of evolve or become irrelevant. So that's very much been, something that I've been working to embrace and to stay current, and to keep the institution current, and adopting modern technologies, both in terms of just efficiency and the expectations that our faculty and students have around the type of software and applications that we deliver. My background is a fairly traditional IT background, I'll say. I have a bachelor's in computer science from UC Santa Cruz, master's in information management from Arizona State. I've worked in this field for about 20 years now, and the career path has been interesting in that it's I guess the best way to put it is like I said, any sort of technology fields, particularly technologists, you really do sort of have to find ways to remain current and remain involved, and adopt your skill set over time. or run the risk of becoming irrelevant or falling behind. So so I think, you know, opportunities to do things like this, participate in panels, remain current on technology, you know, all of that is really important and key to my career path in terms of how I try and remain current, how I try and remain relevant and keep the institution relevant as things are changing really rapidly around us.
Yeah, just from a kind of career perspective, you know, I started off as a student IT employee when I was at UC Santa Cruz, and kind of made acquaintance with the IT staff within the School of Engineering there, and they had some positions open up. So I applied for a position there and started working within the engineering school. Later on moved to working for the central IT department at UC Santa Cruz. And then around the time that UC Merced was launching, I'm originally from the Fresno and Oakhurst area. So this is kind of an opportunity to move back home. So I looked for a way to get in here, and been with UC Merced since then, and started off kind of as a sysadmin and moved up to as a technical lead, and now I'm in a director role within the organization. So that's kind of the similar parallel to the path Nick's took as well, but you know, that's how I ended up here. Yeah, I do have a lot of bugs. I collect Starbucks mugs. Thanks for noticing.
Yeah, so my career path, as far as cloud goes, it's basically like forced on you. You don't get much of a choice unless you just want to not be in tech anymore. So let's see, I don't even know where to start. So I got my master's in computer science at Fresno State, and the reason I actually had job opportunities was because I was doing my master's. My first job was a web developer with the Division of Student Affairs over there at Fresno State because I was doing my master's. Otherwise, I probably wouldn't have gotten a job, and I would have really struggled in private industry trying to find some experience. So I was very lucky in that manner. And after that, the job opportunities were always there after that once I had the experience. I worked for Pelco after that in Clovis. And then they got bought out by Schneider Electric. So I got to see firsthand a tumultuous takeover in private industry. And I was a web developer there. There was no such thing as a cloud. And, you know, that company there was very people-centric. So they weren't big into technology. And even there, the technology, you know, it gets forced on you. So you either have to adapt or your business just kind of dies out. And it's been the same thing. I've worked for startups, and I've worked for friends, and, you know, big company, small company, all the way until I got to UC Merced in 2013. And then that's where the cloud stuff came in. And, you know, just because, you know, the cloud is forced on you doesn't mean all that old experience is irrelevant. You know, the computer science degree gives you that critical thinking and that ability to adapt. And then all that experience also gives you some extra ability to adapt and know how to work in teams. And so the cloud knowledge is just one more thing on top of that, and you just have to be willing to do the learning and adapting. And, you know, once you can do that, it's just another step in your career. So I think that applies to basically everything in technology. As long as you're willing to learn and adapt and stay sharp, you're going to be fine.
Yeah. Kind of carrying on the learning and adapting thing, I just wanted to throw out some ideas on, you know, if you're looking to skill up on cloud services, there are sites like A Cloud Guru or Udemy that offer either free or very inexpensive training on different cloud technologies. It's all self-paced, and you can kind of pick what you want to learn about. And then the other big thing to know about is all of the big cloud providers, AWS, Azure, GCP, offer lots of ways to get free credits for resources there. So, you know, AWS is throwing around $100 credit vouchers like nobody's business. So it's very cheap and easy to get access to an environment and play with it and learn and do it all on your own. You don't have to, have a big investment in servers that are stacked up in the closet of your bedroom, or a bunch of network equipment that you got secondhand from the recycle pile or anything like that. You can get direct access to the same tools and the same services that we're all using to build things that are university scale, or things that are global scale, and it's the barrier of entry is very low. So just get out and play with it and learn and explore and try and decide what it is that's interesting to you.
Yeah, and just to keep adding on to that, so when I evaluate different systems, sometimes we have to just take a look at things before we decide what we want to do. That low barrier to entry is a sign of a good system, actually. So if you're comparing like 3 different systems for the same project, and one of them has no free version or no way for you to evaluate on your own if the system is worth doing, you should take that as a sign that it's not worth using, actually, in my perspective. Having a free version, using it yourself, and being able to decide for yourself is probably one of the most valuable things out there right now when you're evaluating cloud systems.
Were there any tips or advice you would have for anyone that's looking to get into cloud systems? Or there's a lot of people doing like cybersecurity/AI projects, so that may come into there that they may need to use some sort of information tool like that. So would you guys have any tips or advice for that?
Yeah, I'd say I would emphasize the idea, and I know there's a cybersecurity panel coming up next, right, Mejo? So I would really emphasize the idea that cybersecurity in general is a discipline that everybody needs to know and understand, particularly developers, particularly infrastructure managers, and doubly so within the context of cloud services. I have an extensive background in information security as well. I was the campus chief information security officer for a number of years. And I think that's really just a required discipline at this point for anybody who's developing applications that are going to live on the internet. So that's it's not just a security analyst thing. And I see one of our security analysts, James, just joined in. So he'll emphasize these points in the next session. But I really do think that's just a mandatory discipline for people to understand how to secure applications that you're developing, how to secure infrastructure that you're deploying, and how to do it within the context of some of these big cloud systems that are very commonly used now. As far as other tips and advice, I'd say, when infrastructure is code, like it is in Amazon Web Services or Azure, any of the other cloud providers, you can't short circuit your programming skills. You need to know how to develop. Classic systems administrators who used to really only need to be able to write some scripts and things like that. I think the need for software development skills and an understanding of programming languages and programming fundamentals is critical across the board now, because you're no longer physically interacting with things. You are scripting and coding interactions in the physical world to deploy resources and things like that. So languages, scripting languages like Python, understanding XML, which is used a lot in templates for how cloud services are scaled or deployed, things like that is just very critical, and is really a mandatory skill at this point, I think. So
yeah, just to kind of carry on that, around your code that you're developing, having some sort of code repository to store it in, and version control, and knowing how to check in and check out code, and just kind of that general workflow is a critical skill. And also that sort of becomes your documentation of the code as well, and the the systems and the services that you're building. So I guess that just the documentation point was what I wanted to hit on around that.
Let's see, as far as AI goes, let's see, if you want to like be the kind of person that does a deep dive into AI and be the one that builds the frameworks, I'd like to encourage you to do that, because AI is still not very good. You might see these cool, you know, projects, you know, like I just saw one the other day where somebody sort of animated their grandparents' face who was deceased from a long time ago. They just took a couple old pictures and you know, it really touched their parents. That's cool, but that's just very basic stuff in terms of what AI should be able to do. So these are things that look cool, but to me, I think AI is just not very good right now. And this is still a great time to get in and make a dent in the industry. So yeah, get in there and do it if that's what you like. Yeah, that's it.
And then kind of in response to Manjot's question in the text, in the chat around pursuing higher degrees, I think that it depends on what your goals are. You know, if your goals are to be a infrastructure person or a software developer, that I think the experience of actually deploying infrastructure or developing software becomes more valuable initially than a higher degree. I think that starting down a career path where you're actually finding an internship or a job or some sort of project to work on while you're getting your degree is very valuable. And you know, it may be that you work for 4 or 5 years before you decide that pursuing a higher degree is important, just because it may take a while for what you want to do to come into focus and for you to know what it is that you want to work on and pursue a higher education in. On the other hand, if you really want to get deep into the kind of the engineering or the kind of very low level development of things, pursuing an advanced degree and furthering science is an amazing thing. You know, I would never discourage anyone from going that route.
Yeah, I would agree with that. I think it really does sort of, you know, I hate to throw out the it depends answer, but I think in some ways it really does. My own experience, I went back and got my master's degree much later in my career. For my personal experience and perspective on that, it is harder to do it later, I think. You know, it's harder to go back. You know, particularly as you get further along in your career and you're potentially trying to work at the same time. You know, I'm raising a family at the same time. It was stressful. I'm very glad that I did it. I think it, you know, it was ultimately the right call for me. In retrospect, I could have possibly, you know, I might have done it earlier, or just continued education directly, if I had a do-over. I don't know. The other point that I'll make there, I think, is that there are ample opportunities in this field, whether you want to start working, you know, straight after a bachelor's, or also ample opportunities for hands-on relevant experience while you're in school. You know, there are internships all over the place for things like this, to get some real hands-on experience within industry, learning how some of these big companies work, or even some of the smaller ones. I'd highly encourage you to find opportunities like that, because that practical experience combined with a higher degree, you know, you'll be very much in demand. These skill sets, like I said, are incredibly in demand. Yeah. We have a lot of challenge recruiting people with these skill sets and retaining them, because competition is so fierce. So there are ample opportunities regardless of which role you take.
Yeah, I'd say experience matters most, especially in private industry. And for me, the reason I did my master's was because as I was getting near the end of my bachelor's, I felt really uncomfortable with what I knew. And that looking at jobs and job requirements, I really felt like, I just couldn't do it. Maybe it was imposter syndrome. I don't know, but that kind of scared me into doing my master's. And lucky for me, I was able to get a job with the school, and then that sort of propelled my career forward. If I didn't do my master's, I never would have got that job at the school. That's for sure. And yeah, but going beyond a master's, I would only suggest going beyond a master's, like doing your PhD, if research is what you want to do, or if you want to be a professor, that kind of thing. If you want to go into private industry, for the most part, a master's is plenty good.
Thank you. And off of, if students decide to, they try to find internships or try to find jobs right after they get their bachelor's, they graduate, how do you recommend they diversify their portfolio or make it stand out, like the cream of the crop? Would you guys have any tips or recommendations for that?
When I'm looking at, entry-level resumes or folks who are fresh out of school, I really love to see internships, like I said earlier, if there's opportunities for those, examples of development work that they've done, participation in things like HackMerced, any of that sort of extracurricular sort of work that emphasizes some hands-on experience is really, really important, and is kind of a differentiator there, I think. Like Nick said earlier, there are tons of ways to go out and get trained on some of this stuff. Amazon wants to train you. They want you to know this, because then you're going to go and take this to whatever company you work for. And that's what you're going to know. And you're going to go spend a bunch of money with AWS, because that's how you're going to architect your services. So there's an AWS Foundations program. There's I can't remember the name of their sort of entry-level certificate. Cloud Practitioner, I believe, is one of their more entry-level certifications. If I have somebody who can come in and I feel has a solid understanding on one of these major cloud platforms, and can speak that language and understands how solutions are architected in those, that's a huge win and a big big advantage.
And then even if you can't, if you don't have an internship, or you don't have a student job or some sort of, actual work that you're doing, if you've got a side project that you're working on, if you've developed your own web app, if you've built an iOS app for, coordinating, getting drinks with your friends, whatever it is that you've done, show that project as something that you're proud of, and can use an example of the type of work that you're able to complete.
Yeah, absolutely, all of those things. So if you can't get a job, if you can't even get an internship, that's fine. What you got to do is create your own experience. So you got to choose what you're gonna work on, and the good thing about that is that you can actually go by what your interests are. You build something based on your interests, and make sure to double check private industry and make sure there's jobs out there for those things. But if you can show that you're able to learn those things on your own, that's amazing. That's what we want to see in an entry-level person. And then the other thing I like to see is critical thinking, the ability to break things down and analyze something and poke holes in ideas, and do it with a great deal of maturity. When we're interviewing you, we're not trying to like destroy you or anything. We just want to see how you analyze things, and if you're a good fit. Basically, that's what it boils down to.
Roger, are there development languages or platforms or things like that, more from an actual software development perspective, that you would be looking for right now, or would want to see?
Yeah, so as far as the old languages go, I'd say Java is still up there. As far as the newer stuff goes, JavaScript and Node are probably the top languages. If you want to go into AI type stuff, where you're looking at Python basically. But well, actually, if you're gonna like code in Google Cloud Platform, I think was it Go? I forget the language that they like to use, but it depends on the platforms. You just got to read their their documentation. If you really like to code a lot, a lot of these platforms support multiple languages, so you can actually just pick what you like, pick what you're comfortable with. But in general, if you want to cast a wide net, yeah, you got to pick the languages that are used the most. So that's usually like Java, JavaScript. That's where it's going to get you jobs.
Yeah, but I think that showing that you have the ability to pick up something and learn it is the critical skill there. When you're looking for a job, if you can match on 70 to 80% of what they throw in the job criteria, you're doing good. And take pride in what you know and what you've learned, and show that, okay, well, you want someone that knows how to write in Fortran, but I haven't done Fortran, but I've done this stuff in Java and Go, and I'm quick at learning it, and I'm ready to pick it up and move in whatever language or platform you're looking to develop in.
Thank you. And I know we only have a couple of minutes, so I wanted to ask one last question. What would you guys say is the hardest part about your job or your daily activities?
Right now, my office is in my kitchen. It's been a weird year for everybody. So the whole switch to doing everything virtually over Zoom has been a major impact in the last year. Learning how to collaborate with your coworkers in different modalities and not see people face to face has been a fun challenge.
Yeah, I'd say that's kind of true for me. So I like to work in quiet and alone, but it's different when it's not a choice. I do like to go into the office and talk to people, and getting ideas from other people is incredibly valuable. If you're just in a hole and using your own mind for everything, you're just going to be missing things all the time. So you definitely want to keep communicating, even though you're working from home or you're by yourself or whatever it is. Just keep the ideas flowing with other people. And yeah, I mean, that's the best way to work is through ideas.
From my perspective, I think there's a famous quote by Mark Andreessen that software is eating the world. That is, I think that's one of the most challenging parts of my job right now. Is there are literally, there are so many options. There is a SaaS app for anything you can imagine, and in terms of running an IT institution for a very diverse population, among students, faculty, researchers, graduate students, accountants, facilities managers, you name it, everybody. There's an app out there for everything right now. And the challenge from my perspective as an IT leader is to have some sense of order about that and some discipline around the applications that we choose to embrace, the areas that we choose to standardize on, and the way that we enact some discipline, making them all work together and work together well. Roger mentioned earlier that a lot of the work that we do right now is not so much developing custom applications, it's integrating software services and cloud applications to be able to talk with each other and exchange data with each other and work seamlessly. That's hard work, and a lot of it's behind the scenes, and a lot of it, the best case is you don't notice it. It just works. The data is just where you want it to be. Things are just integrated like so. Single sign-on just works across all of these apps and portfolios of apps that we have out there that ultimately everybody needs to interact with to do their business with the university. It's it's a daily challenge, I suppose, because everybody, sees these shiny new things or wants another application or wants a new feature. And it's a lot of work to make all of that stuff work together and work together well, and choose standards carefully, and not annoy too many people because you chose a standard that they don't like. So that's, speaking from the leadership perspective, that's my biggest challenge, and also some of the points that Roger and Nick made around the changed environment that we're working in right now, and the changed sort of rules and ability to collaborate has been a temporary challenge, hopefully, that we're seeing the end of here pretty soon. But yeah,
Hope so.
Yeah, there's definitely a knowledge overload, I guess, in the cloud. Like in AWS, they have more than 1,000 services, and some of those services overlap with each other. So how do you know which one to use? And sometimes you don't even discover the one that you should be using because there's just so much. So it's just, you just learn through iteration and making mistakes and learning and doing better next time. And it's okay to make mistakes as long as you learn from them.
I know we're like a minute away, so I wanted to say thank you for your time, taking the time out on a Saturday morning to come out, especially when you guys' time is so limited, and host this panel for us. If you had any information you might want to pass out to the participants or anything, please let me know. I can always send them any information you might want to pass over. It is 11:45, so again, I just wanted to say thank you so much for coming out and answering these questions and providing all this valuable content.
Thank you.
Thanks for having us.
All right.
Of course.
Good luck, everybody, and enjoy the rest of the day.
Thank you.